Hi everyone, in this video we're going to be adding perpendicular vectors and hopefully generate a procedure for it. So let's start a vector here. Let's get it on the x-axis. That vector is going to be pointing this way. I don't like that. Let's try again. There we go, that's better. And we'll call that one ax. Then we're going to have a y vector that's going to start at the end of the last one. So that's a y. So here's the first step. Draw the x vector, then the y vector. Make sure that the y vector is drawn from the end of the x. The next thing we want to do is draw our resultant vector. And that resultant is drawn from where the first vector began. So it's really our origin. So our resultant vector points from where we started to where we finished, and that would be vector A. It would be the addition of both the x and y components. Next thing we have to do is calculate what the value of A will be. Now, since this is a right triangle, we're just going to use the Pythagorean theorem to figure out the magnitude. Now, what makes it a vector is that this arrowhead has a direction that it's pointing. Now, to find that direction, we will have to figure out the angle that is within that triangle there, angle theta, okay? Now, for this triangle right here, we would be given the x and y components. So if we look, if we want to figure out this angle, we have the opposite and adjacent sides to that triangle. So the trig function that solves for the angle using the opposite over adjacent is the tangent function. So we're going to use the tangent function is equal to the opposite y over the adjacent x to solve for that angle. All right, so you can see I just put the y over x. I didn't use ay and ax, and why I didn't do that is because we could end up with a triangle here that might just have some different labels. So if I call this one bx and by, we would be given the y and the x, and you can see here again that if solving for that angle, we would have the opposite over the adjacent. It would still be the y over the x. If you do that for any quadrant, all right, so you're over here, draw the x first. If you have to do this one first. If you don't draw the x and the y, then this doesn't work. Okay, no matter what, if this is the angle within the triangle, we are always going to know the opposite over the adjacent. Okay, tangent function. And you only got one more option down here, but I'm sure you can guess that it's going to work out, again, the same way. Here's our angle. We still want to solve for that angle. We have the opposite, which is the y, adjacent, that's the x. Okay, so this will always work as long as you do that first one. All right, there's one more thing we have to do, which is take the angle within that triangle that we solved for and make it mean direction. Okay, so anytime we have a vector pointing off of any of the axes, okay, so if I drew another x and y axis here, and I had a vector pointing up in this direction, what direction is it pointing? And remember that the direction that it points is with respect to 0. So this is our 0 degree direction. This is our 90 degree direction, 180, and 270. Since this green arrow is pointing in the second quadrant, the directions within the second quadrant are between 90 and 180. All right, so every single direction, theta given, for anything in the second quadrant, it has to be bigger than 90, but less than 180. So we always have to determine the direction the resultant's pointing with respect to the positive x-axis, which is our 0 degree point, right? So it would be how many degrees of turning would it take to get to this location? And it actually doesn't matter which direction we turn. If I solve for an angle here, for that triangle, and that was 30 degrees within the triangle, this vector would be pointing at 180 minus 30. So this angle right here would equal 150 degrees. And you can see that that's between 90 and 180. If I go this direction instead, all right, that is pointing 30 degrees above the negative 180. Because remember, if we go down from the 0, this would be negative 90. This would be negative 180. This would be negative 270. All right. And so we would go negative angles or clockwise, hit the 180. All right, so turn 90 degrees, turn 180 degrees, turn another 30. You have 180 plus 30, which gives you 210 degrees, but it's negative. Right, so this theta here would be negative 210 degrees. Now, that green arrow is pointing at 150 degrees or negative 210 degrees. And they are the same direction. So no matter whether you turn this direction or this direction, you will always be pointing in the same location. So I'm sure there's the question of what happens if we don't draw the x then the y. Well, it's nothing too bad. So if we drew the y for a first and then the x, our resultant would still be the same magnitude, and the resultant would be pointing in the same direction. However, finding that direction is a little different because the angle that's within our triangle is there now instead of with respect to the x-axis. So if we were going to solve for that angle right here, we would have the opposite over the adjacent, which is the x over the y now. Okay? And if we did that for any quadrant, we would always end up trying to solve for the angle that's touching the origin, and you would always get the opposite x over the adjacent y. So it flips this. Plus it makes it a little bit different on how to calculate the resultant direction instead of just the angle within the triangle. Okay, so it's not a big deal. It's just more standard that most people would follow. But it's not necessary if you can figure out your own way to go about finishing up all these problems. And that's it for this video.